Hello, welcome back once again. Today we have this JEE Advanced math problem. The integral from 0 to infinity of e raised to the power of negative x squared multiplied by the cosine of 10x dx. The most interesting part is that I'm not gonna use the Feynman's technique, okay? Let's do this in a more smarter way. Okay, so let's call this integral I. Let's begin by calling the integral I. So we get that I is same as the integral from 0 to infinity. We have e raised to the power of negative x squared. Now we have cosine of 10x. We have dx. Okay, so this is equal to half, then integrating from negative infinity to positive infinity. You get the idea? E raised to the power of negative x squared multiplied the cosine of 10x and then dx. Okay, that's cool, right? Now let us recall, we know e raised to the power of I theta is equal to cosine of theta plus I sine of theta. And you can see the real part is the cosine theta, while the imaginary part is the sine of theta. So therefore the cosine of 10x is going to be the real part of e raised to the power of, that is going to be 10x I. Where did I put them? Oh my god, that's crazy. Where on earth did I put my I? So it's going to be 10xi, right? So 10x and then I. You get the idea? So our integral, we're going to write it or transform it to 1 over 2, the integral from negative infinity to positive infinity, e to the negative x squared multiplied by okay, we can put the real outside because we need the real part of this integral. Okay, so this is e raised to the power of 10x I and then dx. Now with the help of laws of indices, we're going to add the powers, right? Since we have the same base, that will be e raised to the power of negative x squared plus 10xi and then dx. Okay, so from here, I is equal to the real part of 1 over 2, the integral from negative infinity to positive infinity, e to the negative x squared plus 10xi dx, right? Which I'm pretty sure we're going to write this as the real 1 over 2, the integral from negative infinity to positive infinity, e to the negative 1 into bracket. This becomes x squared minus 10xi and then dx. Okay, let us go ahead and complete the, are we completing the square? Yes, of course. Let us complete the square of the power of e, which is involving a quadratic expression. So we know x squared minus 10xi, this is same as x squared, this is minus 2 multiplied by 5xi. Don't forget we're going to have a 5i squared. Don't forget we need to subtract the 5i squared. So this part here, it's a perfect square, which is x minus 5i squared. Then 5i squared is negative 25. Then minus 25 is giving us plus 25. So therefore, our I, which is equal to 1 over 2, I mean the real part, 1 over 2, the integral from negative infinity to positive infinity, this is going to be e raised to the power of negative, then x minus 5i whole squared plus 25 and then dx. So this is real 1 over 2 the integral from negative infinity to positive infinity. This will be e to the power of negative x minus 5I squared minus 25 and then dx. Okay, so we know we have e to the power of, let's write it down, this is real part 1 over 2, the integral from negative infinity to positive infinity. This is e to the negative x minus 5I squared multiplied by e to the negative 25 and then dx, so which is equal to e to the negative 25 all over 2 real parts, the integral from negative infinity to positive infinity, e raised to the power of negative x minus 5I whole squared and then dx. This is getting more interesting, right? So what are we going to do? Let us make the following substitution. So we're going to let x minus 5I equals t. Now x is equal to t plus 5I, dx will be equal to dt. Now don't forget that our limit remains the same, because if x is approaching negative infinity, t is approaching negative infinity minus 5I, which is same as negative infinity. When x is approaching infinity, t is approaching infinity minus 5I. So this is integral from negative infinity to, oh, don't forget we miss out a lot of things. So this is the real part, e to the negative 25 divided by 2. Then the integral from negative infinity to positive infinity. So what do we have next? So we have e raised to the power of negative t squared and then dt. And don't forget, this is the Gaussian integral, right? So let us recall properly. So we know the Gaussian integral, the integral from negative infinity to positive infinity of e to the negative x squared dx, that this is equal to the square root of pi. Interesting. So therefore we have real part of e to the negative 25 divided by 2 multiplied by the square root of pi. And we're taking the real part, but the number is real, so the real part is what we have right over there. So I is equal to the integral from 0 to infinity of e to the negative x squared cosine of 10x dx, that the result is going to be equal to, we can write that as square root of pi divided by 2e to the 25. So this right over here is our solution. Thank you for watching. Please, if you really enjoyed this video, kindly subscribe to my channel. Also like, comment and share.